Good afternoon, everybody. Thanks for inviting us. My name is Winkler from the University of St. Gallen, Switzerland, and my co-authors are Sebastian Hobert from University of Göttingen, Germany, Antti Salovaara from the University of Aalto, Finland, Matthias Söllner from the University of Kassel, Germany, and Jan-Marco Leimeister from the University of St. Gallen, Switzerland. You can simply follow the link at the bottom or use our QR code to access the paper. So what is the paper about in a nutshell? In our paper we created a multi-channel scaffolding-based conversational agent that is integrated in an existing online video lecture. We compared our conversational agent named Sara with other often implemented conversational agents and found out that our conversational agent significantly improved learning outcomes in a post-test programming task compared to more traditional conversational agents and also compared to the video only. These findings highlight the need to include multi-channel and scaffolding-based conversational agents in online education to generate more meaningful interactions. How do I want to structure the presentation? So first I will motivate the topic, then explain something about already existing conversational agent studies in online education. We'll elaborate on our main research question, the design principles of Sara, how we evaluate it, the main results and learnings, and last but not least the limitations and the future outlook. What we see now in these difficult times is also a trend of the last few years. More and more students enroll in online courses. In these new learning scenarios, student-teacher ratio is usually very high. This is why educators mainly use online videos to transfer their content to the students. Unfortunately, this format does not allow individual interaction between a student and the teacher, and we know from learning theory that individual interaction between a student and a teacher is crucial for learning success. This is why conversational agents gained interest in this field. They might be able to partially solve this problem. Recent studies implemented conversational agents in online learning environments, for example in a forum, as a reflection tool, and so on. Until now, to the best of our knowledge, conversational agents were never implemented on top of existing video lectures, and we want to investigate if these kinds of conversational agents are promising. I've already spoken about existing conversational agents in education. Nowadays, we have a huge variety of conversational agents in education. We have text-based conversational agents where they show questions and learners click on buttons. Some systems use embodied conversational agents that are capable of displaying emotions and gestures. Some have voice output and some have also voice input. The most prominent conversational agent in the field might be AutoTutor from Gresser et al., which has proven to be very successful. Then we have QuizBot, used to learn factual knowledge, which was a paper from last year's Sky. Then we also have ReflectionBot that helps students to reflect about their learning during an online course, and there are more and more studies that use commercially available conversational agents such as Amazon's Alexa or Apple Siri. Based on the existing work in the field and our identified research gap, we asked the question whether multi-channel and scaffolding-based conversational agents layered on top of existing online lectures are able to increase learning success within these lectures. We built Sara based on 3 design principles that we derived from scaffolding and cognitive theory of multimedia learning. First of all, we divided between a main and sub-dialogue. Every time the students didn't know an answer or provided the wrong answer, Sara changed to the sub-dialogue and continued with a scaffolding dialogue that should bring students back on track. To get this implemented, we used a publicly available NLP framework called NLP.js, which showed to be a leading framework according to recent benchmarks. Finally, Sara used multiple channels to interact with the students. She used voice for her responses, and the things she said were then printed on the screen and the students were able to use their voice to communicate with Sara. To evaluate Sara, we used the pre- and post-test experiment design. In our laboratory, we showed every student 2 videos where they were able to interact with one of 4 different types of conversational agents, and we also added a control group where learners watched the video only. The conversational agent interrupted the video 4 times per video. Here you can see an example of a 5-minute video clip where the conversational agent interrupted the video 4 times. Altogether we had 4 different types of conversational agents. One was a non-scaffolding text-based conversational agent, the other one was a scaffolding, text-based, then we had non-scaffolding, text and audio-based, and Sara. And to really show how this worked, we prepared a little demonstration.
So print 123, prints out 123, print 98.6, prints it out. So these are just really the syntax of constants, and without constants we can't write really much.
How would you describe a constant?
A constant is a fixed value.
Yes, that's right. Constants are fixed values such as numbers, letters, and strings. What different types of constants exist?
Strings and numbers.
That's right. We differentiate between string and numeric constants. What is the difference between these two types in Python?
I don't know.
No problem, let me help you. String constants are texts whereas numeric constants are numbers. String constants are texts whereas numeric constants are numbers. Please say next to continue.
Next.
What you just saw in the demo was our conversational agent Sara layered on top of an existing video and also showed the other conversational agents in the study. I will now go to the main results and learnings. When comparing the post-test scores of the students, we were able to support the hypothesis that learners interacting with a scaffolding-based conversational agent show higher levels of information retention and transferability. We were not able to support the hypothesis that voice and text-based conversational agents are superior to textual conversational agents only, but interestingly, we saw an interaction effect between the channel and the scaffolding effect for information retention and transferability. You can see here our descriptive results for information retention and transferability. So for example, students interacting with Sara scored 77.8 out of 100 points and 65.4 out of 100 for transferability. We conducted an ANCOVA with pretest results as covariates, and here you see the mean differences in the scaffolding manipulation for information retention as well as for transferability. For example, the difference between scaffolding and the control group is nearly 20 points in a post-test. 50% of the post-test results are within the error bars you see here. Every time the error bars are not crossing the 0 point, the difference is significant. And here you see the results for the voice manipulation. Our findings confirm the scaffolding effect of past research also in this video lecture setting. We argue that future CAs designs in online education should use speech recognition mechanisms, and finally, we showed that publicly available NLP frameworks are already powerful enough to offer sufficient support for students. Our presentation is of course not without limitations. So first of all, our algorithms not always detected the right and wrong answer of students. Nevertheless, we calculated an intervention selection accuracy score of 95%, which was quite satisfying. It would be interesting for future research to use similar frameworks as we did. Second, we had a laboratory setting which of course is a bit artificial. And there also might be kind of a technology effect when students first use this conversational agent. It would be interesting to implement the conversational agents in real online courses. And finally, we evaluated the conversational agent in a rather narrow context within a programming online course, so other domains might have other characteristics and affordances. Thank you very much for your attention, and I'm happy to discuss our findings with you.